Good afternoon, everyone. We've got a few people who are still joining us, but we're going to get kicked off. I have a feeling we have lots of content to review today. So first off, we're going to see the agenda here. You're going to see a call to order followed by a review of session 1 and 2 outcomes. We're going to talk about our FCEB readiness interviews that we have completed, comparison of BEB versus fuel cell electric buses, presentation of on-site electrolyzer installation by Cummins. We have a QTSEB update, some opportunity for attendee feedback, followed by adjournment today. So we will call the meeting to order at 4:02 Eastern and dive right into the review of session 1 and 2. So session 1 was held on August the 11th and session 2 was held on August the 8th. During session 1, we asked folks, how ready is your organization to transition to hydrogen fleet in the next 12 to 18 months? And the feedback that we received in that meeting is we had about 55% that were not ready, 17% that was almost ready, 11% that was very ready, and 17% that was in the planning phase. During that meeting, we also heard from Brampton and TransLink with some comments and questions from folks at Halifax Transit, New Flyer, Air Products Canada. And Brampton is currently in phase 1 of their project. And TransLink shared that they are participating with the University of British Columbia to conduct some research in the life cycle of batteries as well during that meeting. And then in session 2, we did some breakout sessions and we asked, should CUTRIC proceed with QTSEB joint procurement nationally for fuel cell electric buses and green hydrogen supply? We received a lot of feedback in those sessions. Some of the ones that we heard a lot of was unanimous that joint procurement would be valuable, supportive of the good timing. There is value in exploring a joint procurement, and strength in numbers was a lot of what we were hearing. We also did hear some feedback on value add or added complexity in an already complex landscape. Was a bit of a question there. Importance in a joint procurement with green hydrogen. So that's something that we've heard a little bit of a topic about is green versus other color hydrogens in these situations. And the cost and affordability aspects around adopting this type of technology with some more feedback that we had heard. So we conducted some fuel cell electric bus readiness interviews. We actually were in communication with 6 different transit agencies. And you'll see on the bottom of the screen there, the folks that we were communicating with were all the way from not started and a bit of a progression across the board, right to folks who are already piloting buses. So some of the feedback that we received in those interviews, one of the questions was, has your organization started the fuel cell electric bus planning process? And we had one organization that was plotting 2 different hydrogen buses as part of a consortium. Some had started the planning process, some had not at all. And some considerations for hydrogen buses as part of a broader study. So they had thought about it as part of something larger. And another organization had outlined the steps that they needed to get the pilot project up and running. And currently there is one organization in phase 2 of the planning process. So another question that we asked the interviewees was, what stage of the planning is your organization at for hydrogen fuel cell electric buses? And can you please describe your targeted efforts in the planning process? Some of the responses that we received was a final stage to release the hydrogen fuel cell electric bus feasibility study, RFP. One organization was still in the planning for BEBs and had not started the fuel cell planning. Another organization was very early preliminary planning as part of a pilot project to test and demonstrate hydrogen technology. Another was still in the planning, again, for BEBS, and had not started the fuel cell electric bus planning, was in the stages of learning about those hydrogen options. Another organization was doing a feasibility study. They were in phase 1, had been completed, currently in stage 2, working on the absence of provincial funding. And another organization had communicated that they had refined a plan with a great business case to look at funding options. And another question that we had asked was, what is your intent? To what extent have you engaged your local utility or identified a local hydrogen supplier? And again, the answers were a bit all over the place with this one, where everyone is kind of in a different stage. We have some that had well-established relationships with a hydrogen supplier. Some were communicating and coordinating their plans with a local utility, and they received many offers for a supply of hydrogen for a new facility. Others were involved in a conversation with their local utility and hopefully the potential of green hydrogen supply in the future. There's some that had a brief conversation with their local utility, some that had discussions that were still in the early stages with their local utilities and hydrogen suppliers, and then others who've engaged hydrogen suppliers as project partners to supply green hydrogen. The next question that we asked in this interview was, to what extent has your council, city, region, or province been part of this planning process? For 2 of these folks, it was a limited at that point, so very, very early stages, if at all. And another where they had been presenting in Q3 to council, communicating with the province as part of a project to operate BEBS, and introducing them to hydrogen. Another organization, they were not part of the planning process on their demonstration project, but educating the new mayor's council on hydrogen benefits. And then a different organization had council was involved in the planning process from the start, and they received regular updates. And then the last one that we surveyed in this question said they were working with their council, they were well aligned with the province and making sure they have a solid business case for people who are going to be funding those projects. And then our 5th question is, there anything else you'd like to add to help us understand the potential role of hydrogen in your transit fleet for current and future applications? And so the feedback we received on this one was the decision to transition to hydrogen has already been made, and they're on their way to hydrogen fuel cell buses, aiming to start with 40 to 60. Another organization shared that hydrogen has its place. The ability to achieve outcomes with fuel cell electric buses are reasonably the same as diesel, and that concept is being tested. A different organization said that they're learning more about hydrogen in their province, and if hydrogen is something that they're going to be pursuing. And learning to transition from a fuel cell electric bus fleet will be easier than the current transition, and that would be into using CNG buses. And it's less significant fueling or energy infrastructure that they're going to be responsible for, which will be labor saving. And another organization shared they're looking forward to learning how hydrogen can help the transition of the fleet to meet their zero emission goal. And then our final question that we asked was, how can Qtrix support you? And the feedback here was kind of around the same area with little bits and pieces is the way I'd say that kind of add additional. So understanding, learning, putting a plan in place, educating transit centers, sharing any non-confidential information or studies to better understand how the technology works. They're interested in learning more about hydrogen, support in helping municipalities understand what localized hydrogen production would entail, cost, human resources that would be needed, an advocacy role, getting more funding partners and programs available, and to advocate for debunking myths about hydrogen, review technologies available in an objective way, and to educate policymakers and regional partners. And consistent and continued lobbying to all levels of government was the feedback. So a conclusion on how we're seeing that Qtrix is going to be able to help, you're really looking for us in an advocacy role, knowledge sharing and debunking those myths around hydrogen. A joint procurement is of interest to some, and consistent and continued lobbying to all levels of government seems to be the outlook from folks. So next, we're going to shift it over to Roberto, who's going to give us a comparison of BEB versus fuel cell electric buses.
Thank you so much, Jess, and welcome everyone. Thank you for joining this call. My name is Roberto. I'm a senior scientist working with Qtrix. I work with our SEB consulting services on the research side, and I manage the IP development for Qtrix, so I'm glad to be here. And my intent here today is to play a little bit of a devil's advocate, and so please allow me to provoke some thoughts on you, and that I guess would be a great for starting a great discussion around fuel cell electric bus technology. And again, as the title says, we're going to compare it with a battery electric bus technology there. So I'm going to talk briefly about the typical energy consumption that we have been observing throughout both predictive modeling and empirical data collection as well. And then we're going to talk a little bit about the cost, and that includes the vehicles, the energy and fuel, and associated infrastructure for charging/refueling. I'll talk briefly about the environmental life cycle analysis that we have been conducting for some of the agencies, some of the results, again, comparing battery electric and fuel cell electric buses and diesel technology as well. I'll talk about success rates, which is a great topic of discussion because usually the number of buses that you need to replace one diesel bus is not one, it is a bit more. And there's a difference between battery electric and fuel cells. So I'll talk a little bit about that. I'll talk of some unknowns at this point, such as, for example, real estate considerations, real estate costs that plays a significant role in the economics of those two technologies in there. And one of the also unknowns here lies around the fuel supply chain for hydrogen. So I'll include those in the discussion as well. So Jess, if we can move to the next slide, please. Okay, so starting with the energy consumption and cost. So a typical energy consumption for a battery electric bus is a 1.5 kilowatt hour per kilometer. And again, that depends strongly on the local operational conditions, your ridership, your ambient temperature. But one reference number that we can stick to it for now is 1.5 kilowatt hour per kilometer. For fuel cell electric bus, if we have the same measure of a typical energy consumption on a typical demand, typical loading, typical topographical condition, is 9.5 kilograms of hydrogen per 100 kilometers traveled. Now, from a purely energy standpoint, we would need, if we would need like energy to in an electrolyzer to produce that hydrogen, if we do the conversion, that translates into 4.75 kilowatt hour per kilometer with the typical electrolyzer efficiencies that we observe out there. And that is enough to power 3 battery electric buses. So that is one red flag for fuel cell electric buses, because from a purely energy standpoint, they are not as efficient. Again, you need to convert energy to hydrogen, hydrogen back to energy, and then power your bus if you're looking at green hydrogen or electrolytic hydrogen. So 3 times more energy to power a typical vehicle. If we look at the costs down below in this table, I have like very general numbers in here to compare for diesel, battery electric, and fuel cell as well. In the first column, you'll see the vehicle cost. So typical diesel, $700,000, typical BEV, $1.2 million, typical fuel cell electric buses, bus 1.6 million. Again, those numbers are just reference numbers. Cost depends largely on the volume of procurement and other things as well. But those are reference numbers that we have been observing. If you look at the second column, which is the energy and fuel cost, and if you assume a typical 12-year life cycle, 80,000 kilometers per year, you will have about $650,000 of fuel costs for diesel. For battery electric, that again depends a lot on the jurisdiction that you are. If you are able to produce cheap electricity, inexpensive electricity in your province. So in Ontario, we are looking at approximately $288,000 for the life cycle of the vehicle, again, 12 years. And for a fuel cell, that is a big uncertainty, but there's a lower boundary because again, if you need 3 times as much electrical energy to power a bus, let's just take that lower boundary and multiply the energy cost of a battery electric bus by 3, and we'll have more than $860,000 with fuel costs. Of course, the cost is larger than that. It's not just the cost of electricity, of course, but again, that's a lower boundary for this comparison here. If we look at infrastructure, this is not just the fair comparison with diesel because I did not include any cost here. Usually the infrastructure for diesel is out there, but in any case, it should be a cheap infrastructure. I'll not dive much deeper into the assumptions here for battery electric or fuel cell because those are not very large when you do like a per bus comparison. And again, it depends on the size of the deployments. We have been observing similar costs for like procurements of the size of a few hundred buses. And if you look at the total at the last column, again, you'll have the diesel still the cheapest one, even though things are changing fast with the price of diesel that is changing drastically over the past few months. With the battery electric just slightly costly, and with fuel cell electric bus considerably more costly than the other 2 technologies in here. Next slide, please, Jess. If we look at things on the environmental lens, we'll observe that there's still not a great business case for hydrogen buses. So the first column that you see is diesel bus life cycle emissions, and that includes the vehicle manufacturing, the manufacturing of the producing of the fuel, all of the maintenance, the refuel of the bus as well. So it's a very comprehensive life cycle analysis for the life cycle of all of the operation of those vehicles and technologies. So again, the first bar there is diesel. The second bar is battery electric bus with electricity as a reference. This is a work that we did for an Ontarian transit agency. So electricity is in Ontario has a low carbon intensity factor, so you can save overall more than 80% in the emissions, again considering everything: vehicle manufacturing, the operations, the maintenance, everything. If you look at hydrogen, then we have the 2 last columns, and that is SMR hydrogen, without bothering too much on capturing the CO2 emitted. Actually, yeah, actually this is blue hydrogen, so it captures a significant amount of hydrogen still in the production, but still emits almost as high or a bit more than diesel in this case. And only with green hydrogen, the most expensive form, electrolytic hydrogen, you'll have substantial savings, but still not as large as a saving when you compare it to BEB, because of the orange bar there, the fuel supply. Again, we need 3 times more energy in terms of, if you compare just in terms of energy to power that bus. So that naturally has a larger environmental impact. So overall, per battery electric bus, you can save approximately 1,200 tons of CO2 per vehicle in Ontario, but with fuel cell electric bus, even if you use electrolytic hydrogen, you can expect to save a little bit less, just above the 1,000 tons of CO2 equivalent per bus. And that's a good enough saving. But again, we are comparing the holistic thing here, economics and environmental as well. Next slide, please. Okay, success rates, and that is almost the end of my presentation. But if we look at the success rates, we have conducted predictive modeling work and feasibility analysis for several agencies so far. And we are showing 4 agencies here for which we conducted both battery electric and fuel cell feasibility analysis. The first group of bars there is battery electric, charging only at the depot. The first set of columns there, medium and heavy duty. So you can see, like, for medium duty, like you can expect like between 50 and 80% of your blocks to be successful. And what I mean by that is that if you replace if you electrify one transit block with just one zero emission bus, between 50 and 80% of those blocks would be successful, would be capable of accepting that electrification successfully. In the heavy duty cycle, things get a little bit worse. And so it goes with the comparison. The middle section of the graph there, where you can see the battery electric charging in the depot and on route as well, you can see a significantly improving the success rates, because they range from 70 to virtually 100%. So it's a huge improvement when you compare to depot only charging, but still, like, it's not a one-to-one replacement. That's what I'm trying to say. Not all transit blocks can be electrified using only one battery electric bus, even if you include on-route charging. And the last set of columns there, which is fuel cell electric buses, without considering refueling during the mid-service, you can see that the success rates are slightly lower than the BEB counterpart with on-route charging. They're definitely larger when you compare BEB's charging only at the depot, but they can be slightly lower when you compare with BEBs that have access to on-route charging. That is a disadvantage of FCEB's application for transit agencies as we see it for now. Next slide, please. So there are a few unknowns, real estate and space constraints. So with battery electric, there's a huge constraint, like for most of the transit agencies out there. And that is space both in the garages and across the city as well. Like you would not imagine the amount of space that is required to install all the transformers, the switching gears, the power cabinets and the masts and the bollards and all of the electrical infrastructure to install on our on-route charger. So in that sense, fuel cell electric buses came the winning in that aspect, because the space constraint would be confined to the garage. And it is a much more compact fueling infrastructure in that sense. The fuel supply chain, it's really, I believe, like a well-established problem for everyone in this call. For battery electric, the infrastructure needs to be scaled up, and that's not an easy task at all. But it's established technology out there, and for fuel cell, technology is proven, but the market is still like very incipient. So it's not an easy task. There's a lot of uncertainty on the fuel supply chain for hydrogen currently. And my last slide, please, Jess. Okay, so just to leave you guys with the questions to be answered here. So we have seen that battery electric buses come on the winning side when it comes to energy consumption, cost, environmental impacts, success rates, and the energy or fuel supply chain. And we have uncertainties regarding real estate considerations. Are those uncertainties enough to flip the business case from fuel cell towards from BEVs towards fuel cell? That's a question that I'll leave you guys to think about. And that was all. And hopefully I'll get a lot of questions from you, and hope to engage in a rich discussion. Thank you all. Back to you, Jess.
Does anyone have questions or feedback that they want to provide to Roberto today? If not, his email is always open, as is mine.
Can we ask verbally?
Roberto, are you comfortable with that?
Yes, of course.
I love putting him on the hot seat, so absolutely, go ahead.
So if you go to the costing, the first slide, I will wonder why you use 20 cents per kilowatt hour for electricity. I know you mentioned it's Ontario, but Ontario never charged that much for electricity at any moment of the day.
Yep. So in Ontario, we do have volumetric costs, but we do have power demand costs, and we do have something called global adjustment, which is a big portion of the electricity bill, like maybe between 60 and 80% in some instances. So this here is just like a normalized way of calculating the cost back here, because it's really not 20 cents per kilowatt hour, but you have to include all of those power demand charges and global adjustments and all of those other fees as well. So we just like included those in these fixed rate here, just to provide a means of comparison, really.
Okay, and I don't get why you didn't include any diesel infrastructure costs, because I know the pump and everything is already there, but still you have to consider the depreciation of the installation.
Yes.
And also the decommissioning fees, which is quite significant for diesel. So it's yeah, that's all.
You're quite right. Yes, that's a gap on our presentation here, and diesel infrastructure depends a lot, like on the status of your agency. Some of the agencies in Ontario, they are having like old infrastructure, old diesel infrastructure. They just don't want to replace those because they are waiting for the next technology to come, instead of just expending precious dollars on technology that's being phased out. So it's a bit of uncertainty here in terms of is there a value to put there for charging infrastructure? And I wanted to provide like a really good test for BEVs against diesel and fuel cell against diesel as well. So, but you're quite right. So we should improve a little bit the business case of both BEBs and FCEBs when we throw in the infrastructure cost of diesel in there as well.
Yeah, and the fuel cell infrastructure is, I don't know what you include there, but it's way too low. I'm not sure what you include.
Well, yeah, so that is on a per bus basis for deployment of a few hundred buses. That is the basis of calculation there. But the rate that we are assuming here for cost of infrastructure is $900 per kilogram of storage. So, and again, that depends a lot. Like, to provide with an accurate number, we would have to discuss whether you're looking at gaseous storage or liquid storage, or if you're going to deliver, or is there a pipeline, or is there electrolyzer on site? So anyway, this is just supposed to be like a reference number, order of magnitude kind of thing. But at least for the average studies that we conducted in Ontario, those are numbers that we are currently observing what people are aiming for if they go with fuel cell, really.
Okay.
I would confirm on a per bus basis, it's not far off from what we calculated at full conversion.
Thank you for that, Erin. Any other questions?
But I would just ask Erin, if you calculate it, what is it include in that? Do you have the tank, the compressor, electrolyzer, reverse osmosis?
Yeah, that's for that pricing. It's a liquid fueling station. We are pricing it based on about 4,000 kilograms per day size station. That pricing came to that, with the filling station filling approximately 42 buses per dispenser, I believe. And
the hydrogen get transported to the refueling.
Yeah, that was delivered. So that would not be like, it wouldn't be including electricity prices. That would have included delivered fuel. So that would just be the cost of the equipment itself. Because
in that situation, if it's transported there, it's probably because it's gray hydrogen.
Well, no, in our case, we are still assuming liquid green hydrogen, because we would not proceed with gray hydrogen. It's not part of our project plan. It just doesn't exist today. So.
Okay.
It's all theoretical.
Yeah, it's just that I studied the cost of refueling station from a green hydrogen, and the cost should be much higher than that. This installation is scary if you transport the hydrogen there, which means it's coming from a production site elsewhere, and in most cases it's because it's gray hydrogen, or you're kind of throwing the cost of the installation on someone else, but ultimately this cost needs to be absorbed by someone. So it's kind of a bit misleading in terms of cost for the fuel cell. I think like there's other costs associated with it. Like beyond this, you'd have a maintenance contract that would be a certain amount per station per year as well. All on top of that, that sort of covers that, and like your supply agreement as well. So I think the oversimplification here is stating sort of the energy side of things as opposed to the cost of hydrogen delivered or dispensed. It's easier to sort of understand in terms of this, and like this seems to be including a cost of green and plus the delivery on top of that. But yeah, right now distance definitely makes a difference for us. We're assuming to move forward, we would have a source of liquid hydrogen, green hydrogen, within 200 kilometers of our location.
Thank you, Erin. That's actually really helpful. And I appreciate you being able to kind of confirm some of the information there that Roberto was showing from your perspective as well. Is there anyone else who has questions at this point? All right, so we will move along. So we had planned to have a presentation. We were actually going to have Cummings do a presentation for us today, but I believe Omar might be having technical issues unless he's hidden here and I'm not able to see them. I don't believe he is able to join today. So what we're going to do is we'll see about maybe adding this presentation to the next webinar. We do have one more left in this series, so we do have an option for that as well. I'm just going to bump ahead in the slides here, not to give away anything he was saying, so I want to try and do it very carefully, and we're going to move into the QTSEB updates. And Jessica, I will hand the virtual mic to you. Thank you.
Thank you very much, Jess. This is a quick update on the QTSEB Joint Procurement Initiative. So as a recap, QTSEB is an independent standalone organization that will lead Canada's first national joint procurement program for electrified public transit infrastructure, focusing on turnkey zero emissions transit solutions for small to mid-sized transit agencies. It will provide a uniquely synergistic, comprehensive, and cost-effective process for joint procurement nationwide. Next slide, please. So we're pleased to say that we are in the midst of round one of joint procurement. And for this round, the clients are seeking to procure 14 battery electric buses, chargers, both in-depot and opportunity chargers, civil works for the installation of chargers en route and in depot, as well as accompanying infrastructure, including electrical support infrastructure. And for round one, we're pleased to have both Burlington Transit and London Transit Commission as clients seeking to procure those 14 battery electric buses, chargers, civil works, and accompanying infrastructure. To that end, both those transit agencies are represented on the QTSEB Project Steering Committee by Sue Connor and Kelly Pledge-Sneed. And in terms of a progress update, we've had quite a bit of movement since the last time I presented to this particular webinar. An expression of interest was submitted to the Zero Emission Transit Fund in December 2022. A press release announcing the creation of the Joint Procurement Initiative was also disseminated in February 16th specifically, 2023. We also have ongoing consultations for transit and utility partners that are ongoing. We are about to have the second consultation with Burlington Hydro, Burlington Transit, London Hydro, and London Transit Commission later this week. And we're also pleased to inform you all that the request for information for round one was launched on February 17th. The RFI text and frequently asked questions are available on the QTSEB website, linked in the text, and I can also include that in the chat. And we also have uploaded the RFI to the MERX platform for those of you who would like to have a look. Questions that were posed before the February 28th deadline for questions and answers have been revised on the website. So all of those are there for you to see. And I can actually say as of today, we're going to be revising that FAQ again to incorporate some more recent questions we've received from potential suppliers and interested transit agencies. And then finally, the deadline for interested suppliers to participate in the RFI is Friday, March 31st, 2023. So any potential suppliers or transit agencies interested in learning more about the Joint Procurement Initiative are encouraged to contact me at info2@qtseb.org. Thank you.
Thank you so much. And we'll give an opportunity if anyone has questions for Jessica. And Jessica, maybe you can drop that email in the chat. That way folks can easily access it. So we're going to move on to our next little bit of business here. We're going to get some feedback from the folks that are in the meeting today. And we have a poll that we are going to launch. You're going to see it pop up on your screen. We're not going to share the results today with you. We are going to share the results in our next webinar. But we'll go through the questions here. Don't feel like you have to immediately rush to answer, but I can kind of see as the answers are coming in. The first question that we've got up in this poll is, what is your greatest concern moving into fuel cell electric bus use? We've heard a kind of a variety of feedback at this point, and I know it's going to be really hard to kind of pick that number one concern, but I want to get a bit of an idea on really, if you had to focus in on one particular item, if it's going to be the hydrogen cost, so that's per kilogram, infrastructure cost, if it's green hydrogen availability, funding assistance, lack of data, or maybe there's something else. Maybe there's an other, and if you want to capture that other with if you want to provide some more feedback, maybe Jessica or Tatash can drop my email address in there, and I can make sure to kind of capture that as well if you want to send more details about what your other may be, because you're really feeling like it's not one of these other 5, it's something that's really pressing for you. Okay, so if you want to take a moment with that particular one. All right. And then our next question is on staffing availability. What staffing availability do you have to support your hydrogen initiatives? So maybe you're a smaller organization and you've got no staff at all, or it's not something that you've started to put budget towards. Maybe you have one person who's dedicated, maybe it's only half a person. If it's only half a person, then I would say instead of no staff, maybe leaning towards one, if maybe it's part of their role. Maybe you have 2 to 5, maybe you're a larger organization and you have 5+ people that are there to support and help you move through. And then our final question around the color of hydrogen. What color hydrogen would you be in support of for a joint procurement? So our options here are green, blue, and other. And this would be, if you were picking green, it has to be 100% green. Blue, obviously blue is preferred, but maybe it's acceptable if it's something else, but that's your preferred. And then other is maybe you're quite comfortable with your organization with gray hydrogen, so you would be selecting other. All right, so thank you all very much. So the next item is adjournment, and I see Yawen has added my email here. So feel free to shoot me an email if there's something that you've kind of been triggered by this webinar today. And apologies again for not having that Cummings presentation. We'll see if we can get that added into our next webinar. And if you watch our newsletter and our social media, as well as even if you want to know when that date is, you can shoot me an email and I'll be sure to send you the registration once we have that date confirmed. Thank you everyone for attending today.